Azetidine. It is a four-membered heterocyclic ring system. It is saturated. Its molecular formula is C3H7N. Let us see the structure. So, structure 4 is azetidine. It is trimethylene imine. So, it contains 1, 2, 3. 3 CH2 groups and a NH. Therefore, it is trimethylene imine. These are structures 1, 2 and 3 are the unsaturated forms of azetidine. So if we look at the structure 3 and 2, they contain one double bond. So this is azetine, one azetine. So the double bond is between the N1 and C2. It is called one azetine. It is partially unsaturated form of azetine. Similarly, structure 3 is 2 azetine. So the double bond is between second and third carbon. It is 2 azetine. It is also a partially unsaturated form of azetidine. So next, the another unsaturated form of azetidine is this azet. So it is a four-membered system with two double bonds. So aza cyclobutadiene. Azacyclobutadiene. So this azacyclobutadiene is known as azet. So it is a completely unsaturated form of the azetidine and it is non-aromatic. It is not aromatic. Azacyclobutadiene is not aromatic. So partially unsaturated ring is called azetine. We have seen one azetine and two azetine. So azetidine is the name given to the completely saturated four-membered nitrogen-containing compound. That is structure 4. So it is also known as trimethyl imine. Azet is anti-aromatic. So azet, structure 1 is anti-aromatic and it is not stable. So the bench azets, this is a bench azet such as phenyl bench azet, structure 5 is more stable and has been prepared. So bench azets are stable compared to the azet. Structure 1 is azet, structure 5 is bench azet. So bench azets are somewhat stable compared with simple azet. However, here we are concerned with the synthesis and reactivity of azetidine, that is structure 4, the completely saturated form. So synthetic azetidine derivatives have also been not yet yielded any useful results for pharmacological evaluation. So azetidines, they do not have any pharmacological activity. So far they did not exhibit any pharmacological importance. So however, L-azetidine 2-carboxylic acid is naturally occurring anti-metabolite of proline and it has been isolated from liliaceae. So L-azetidine 2-carboxylic acid has been isolated from natural sources. So coming to some of the physical properties of the azetidine. So let us see the properties of azetidine. This is azetidine, DIDINE. Azetidine is a liquid having boiling point about 61 degree centigrade and it has ammonia-like water, that is ammonical water. So azetidine is soluble in water and other lower azetidines are also soluble in water and when exposed to air, they will fume. On exposure to air, azetidine will produce fumes. So azetidine is a stronger base compared with the corresponding three-membered compound aziridine. So three-membered heterocyclic ring system containing NH and two CH2 groups is aziridine. It is less basic compared with azetidine. So azetidine is more basic compared to aziridine. So coming to the methods of synthesis. So pyrolysis of cyclopropyl azides. This is a method for the synthesis of the one azetine. It is not a method for the synthesis of azetidine, but it is a method proposed for the synthesis of one azetine. So a useful route to one azetines involves pyrolysis of cyclopropyl azides. So pyrolysis of cyclopropyl azides gives an intermediate, so which rearranges to a four-membered ring system and then stabilizes to form azetine. One azetine is formed. So azetidines are mainly prepared by two important reactions, that is intramolecular cyclization reactions and the other one is cycloaddition reactions. So it is a photocycloaddition. It is also meant for the synthesis of the azetines, partially unsaturated azetidine. It is not a method for the synthesis of azetidine. It is a method for the synthesis of one azetine. So they are prepared by a 2+2 cycloaddition reaction. So let us see one example. This is a method where a benzonitrile is reacting with 3,3-dimethyl 2-butene. 2,3-dimethyl 2-butene reacts with benzyl nitrile in N-hexane on exposure to light, resulting in the formation of a azetine derivative. So it is 2-phenyl 3,3,4,4 tetramethyl 1-azetine. It is also a method for the synthesis of azetine but not azetidine. So now let us see some of the methods employed for the synthesis of the azetidine. So azetidine and its derivatives have been prepared by a number of methods which include intramolecular cyclization reactions and cycloaddition reactions. So these reactions involve the intramolecular cyclization reactions and cycloaddition reactions. These are the two important methods which are generally employed for the synthesis of azetidines. However, these four-membered rings are somewhat difficult to form compared to the three-membered ring systems, because the two ends are not in close proximity. So therefore, formation of these rings is somewhat difficult. Four-membered rings is somewhat difficult compared with the corresponding three-membered ring systems. Let us see a method for the synthesis of simple azetidine. So gamma halo alkyl amines in presence of base gives azetidine. So these gamma halo alkynes in presence of a base on treatment with a base gives azetidine or its derivatives. It is an intramolecular cyclization reaction. So for example, let us see the synthesis of parent compound. It is azetidine. It is obtained by the treatment of this gamma bromo propylamine with hydroxide ion. So it is a nucleophilic substitution reaction. So bromine, this bromine atom is displaced here. It is moving out as Br minus and this nitrogen will attack as a base, and it is followed by loss of H plus. This is followed by loss of H plus from NH2, resulting in the formation of simple azetidine. However, this method gives poor yield of azetidine. So because the rate of ring closure is very slow. So because four-membered rings are not conformationally suitable for formation. The two ends are little far away, and conformationally it is not easy to bring these two ends to form a four-membered rings. So best results are obtained when the halogen is primary or secondary. So halogen must be CH2Cl, or it must be or CHCl. Yields are poor with the tertiary alkyl halide. So the ring closure is facilitated when some substituents are present in the alkyl amines. In the alkyl amines, when some substituents are present, ring closure is somewhat easy and it gives 80% yield of the product. So we will see an example here. So this is a substituted alkyl amine. So CH3 on nitrogen and two CH3 groups here, and this bromine is removed as Br minus, and this nitrogen will attack as a base, and this is followed by removal of this H plus. This H plus is removed. This H plus moves out and we get a N-methyl 3,3-dimethyl azetidine. So N-methyl 3,3-dimethyl azetidine. So the yields are high when substituents are present in this alkyl. So therefore, these are azetidines are prepared, simple azetidines are prepared by intramolecular cyclization of the gamma haloamides. Gamma haloamides. So aziridines, the three-membered ring expansion takes place to a four-membered ring system when treated with this sulfurane. Sulfurane. So this aziridine, it is substituted. Here we are making use of 3,3-dicarbomethoxy aziridine. So it is a aziridine, three-membered ring system. It is treated with sulfurane in benzene at room temperature, resulting in the formation of a substituted azetidine. So it is 3-benzoyl 3,3-dimethoxy carbonyl 1,4-diphenyl azetidine. So it is a substituted azetidine. So aziridines are converted into azetidines. So three-membered ring expansion takes place to a four-membered ring system when treated with this sulfurane. This is sulfurane. Sulfurane aziridine is treated with sulfurane at room temperature. So from gamma lactones, this is another method. So in this method, gamma lactone is converted into gamma lactone. A gamma lactone is converted into azetidine 2-carboxylic acid. It has a sequence of reactions. This is the azetidine 2-carboxylic acid. So this is treated with hydrogen and palladium carbon. Reductive dehydrogenation gives this azetidine 2-carboxylic acid. So gamma lactone is first treated with PBr3. PBr3. So it forms a ester. It is converted into a ester. Let us see the steps here. This should be CH3. Gamma bromo. Here we get methyl alpha gamma dibromobutyric. It was obtained by bromination of gamma butyroactone. Gamma butyroactone on treatment with PBr3 gives this methyl bromobutyric. Methyl bromobutyric is obtained, and this is treated with excess of methyl alcohol. The resulting product is treated with excess of methyl alcohol. Then the resulting compound was refluxed with benzylamine. Benzylamine, it is a secondary amine, diphenyl benzylamine. To give 1,2-disubstituted azetidine. So then the resulting compound was hydrolyzed to the corresponding carboxylic acid, and finally hydrogenolysis with palladium carbon gives azetidine 2-carboxylic acid. So gamma lactone is converted into methyl bromobutyrate. So gamma lactone on treatment with PBr3 followed by treatment with the methanol, it gives this methyl butyrate, gamma bromo methyl butyrate, which then react with diphenyl methylamine. So it is diphenyl methylamine. It reacts with diphenyl methylamine to form an azetidine derivative. So it contains this ester function COOCH3. This is hydrolyzed to carboxylic acid with barium hydroxide. Then hydrogenolysis. Hydrogenolysis will remove this. Hydrogenolysis will remove this alkyl group. This alkyl group is removed by the hydrogenolysis. So this is another method for the synthesis of simple azetidines. Next, intramolecular participation. So here there is an oxime. Oxime is converted into a azetine N oxide. Azetidine N oxide. So it is a ketone. It is a substituted ketone. So ketone, and it also contains a OH group. So this keto group reacts with hydroxylamine to form an oxime. Then this oxime is involved in a intramolecular nucleophilic substitution reaction. So meanwhile, this OH group is converted into a better leaving group. OH is a poor leaving group. It is converted into a tosyl group. It is paratoluene sulfonate, which is a better leaving group. And this nitrogen atom will attack as a base in the ring closure reaction. So in this reaction, we get a N oxide. It is azetine N oxide. It is also a method for obtaining azetine. Azetine N oxide. So reaction of amines with halogeno-alkyl oxalates. It is halogeno-alkyl. So halogeno-alkyl oxalate. This is a 3-membered heterocyclic ring system containing a methyl halide side chain. So it is epichlorohydrin. So epichlorohydrin is treated with amines. So amines react with epichlorohydrin to give 1 alkyl amine, 3 chloro, 2 alkanols. So initially we get 1 alkyl amine, 3 chloro, 2 alkanols. So 1 alkyl amine. So 1 alkyl amine, 3 chloro, 2 alkanols. So epichlorohydrin reacts with the primary amine to form a 1 alkyl amine, 3 chloro, 2 alkanols. This intermediate compound 8. This undergoes cyclization. This will then undergo cyclization. So here this chlorine is removed and the nitrogen atom will attack as a base. It will attack as a base and this hydrogen is removed as H plus. This hydrogen goes out as H plus, leaving the electrons on the nitrogen, forming 3 hydroxy azetidines. So by this procedure, various azetidines have been prepared. This is a tertiary butyl alkyl amine reacting with epichlorohydrin, resulting in the formation of a substituted azetidine, which is then treated with methyl chlorosulfonate to form a mesylate. This mesylate is then treated with nitrous acid, where mesyl group is replaced by NO2. It is treated with silver nitrate, where it undergoes nitration, and then finally it is treated with nitric acid to form a trinitro derivative of the acetylene. These are additional examples. There is one more example here. This is another example. This is an example of this. This is another example of this reaction of epichlorohydrin with primary amines. The description of this mechanism is given here. To this, it is the description of the mechanism. These are some of the methods of preparing acetylines. Here we can concentrate only on the methods of synthesis of simple acetylines. 2 or 3 methods. You have to learn 2 or 3 methods of synthesis of simple acetylines. Acetylene is not required. It is additional information. So coming to the chemical properties. So 4-membered heterocyclic compounds display several of the reactions characteristic of their lower analogues, but with lesser degree of reactivity because of decrease in the ring strength. So 4-membered rings having less strain compared with 3-membered ring system. Therefore, their reactivity is slower compared with the corresponding 3-membered rings. So mainly these are ring opening reactions. 3 and 4-membered rings generally undergo ring opening reactions. These are the main reactions to get relief from the strain. Acetylene ring is cleaved more sluggishly than acetylene. That is slowly. Acetylene ring is cleaved or opened. Is cleaved or opened more slowly compared with the corresponding 3-membered ring system acetylene. So the cleavage is accelerated by the presence of acid catalyst. So cleavage is accelerated by the presence of acid catalyst. The opening of acetylene in the presence of hydrochloric acid results in this 3-chloropropylamine hydrochloride. It is 3-chloropropylamine hydrochloride. So acetylene, this is acetylene. Acetylene when treated with 2 molecules of HCl. So the ring opens, the heterocyclic ring, the 4-membered heterocyclic ring system opens. So to form 3-chloro propylamide hydrochloride. It is in the form of salt. Formation of azetidine derivatives. This azetidine contains NH. This NH behaves as a secondary aliphatic amine. This NH group which is present in azetidine, it behaves as a secondary aliphatic amine. Therefore, azetidine undergoes certain reactions which are shown by the secondary aliphatic amines. So, for example, azetidine, it forms a salt with carbon disulfide. When treated with CS2, it forms a salt. Similarly, when treated with nitrous acid, it gives nitrosoazetidine. N-nitrosoazetidine is formed, and similarly, it forms N-hydroxymethyl. It forms N-hydroxymethyl azetidine with formaldehyde. So let us see, formulate these reactions. So formation of salt. So azetidine, this is azetidine. When treated with CS2, it forms a salt. When treated with nitrous acid, it forms a nitroso compound. This is nitroso compound. This nitroso compound on reduction, it is converted into amine. When treated with peracid, it is converted into a nitro compound. So on reduction, it forms amine. On oxidation, it forms a nitro compound. And this azetidine, once again, when treated with formaldehyde, it forms this N-methyl hydroxyazetidine. Similarly, it can form quaternary salt. N-methyl azetidine, when treated with alkyl iodides or alkyl halides, it forms a quaternary salt. So this is 1,3-dimethyl azetidine when treated with methyl iodide. 1,3-dimethyl azetidine when treated with methyl iodide, that is a alkyl halide, it forms a quaternary salt. It is a quaternarization reaction. The nitrogen atom is basic in nature. It can form a quaternary salt. So photochemical reactions. These are not much studied. The photochemical reactions of azetidines have been well investigated, and there is a need to carry out more studies in this aspect of photochemical reactions of azetidine. So there is one example. Here we have shown one example, one representative example, one representative system or example that has been studied by the Padwa and co-workers is azetidinyl ketone. Azetidinyl ketone, that is 10. This is azetidinyl ketone on irradiation rearranges to diaryl pyroles. So two derivatives are obtained. Two derivatives of pyrrole are obtained. Two diaryl pyroles are formed, 11 and 1. It forms two diaryl pyroles. So on irradiation, this azetidinyl ketone on irradiation with light, it forms a biradical, it forms a oxyradical. You can see unpaired electrons here. Two unpaired electrons. Then there is a shift of hydrogen. This hydrogen will shift to oxygen to form another biradical. We get another 1,3 biradical. So 1, 2, 3. There must be electron here. Not. There must be. So this green here from here we must have one electron here. So initially these electrons will have same spin. It is a triplet biradical. It is a triplet biradical initially, which is then converted into a singlet biradical and then undergo rearrangement. First, it is a triplet biradical which will be converted into a singlet biradical. Forms then a singlet biradical and then it will undergo rearrangement. These are the intermediates. These are the intermediates. These two are the intermediates after rearrangement of the singlet biradical, which are then converted into the substituted pyrroles. So here 1 tertiary butyl, 2,3 diphenyl pyrrole. This is tertiary butyl, 1 N tertiary butyl, 2,4 diphenyl pyrrole. So this is N tertiary butyl, 2,3 diphenyl pyrrole. So here the mechanism is given. So a mechanism consistent with this rearrangement has been formulated. It involves an intramolecular hydrogen shift. In the first step, there is a intramolecular hydrogen shift, and we get a unpaired biradical. That is a triplet biradical. Spin unpaired 1,3 biradical means it is a triplet biradical intermediate. So then spin inversion results in a singlet biradical. Then spin inversion followed by ring closure yields a intermediate aja bicyclo 2,1,0 pentane, an intermediate which is transient. It is a transient intermediate. So this readily loses a molecule of water. It loses a molecule of water. It loses a molecule of water to give disubstituted. This is the mechanism of the above reaction. These are some of the important reactions of acetylene. The photochemical reactions on acetylene are very less studied. This is one of the examples. So the other reactions are, before this we have seen quaternization reaction. This is quaternization reaction. Next, acetylene involved in reactions with CS2, formation of salt nitrosation and formation of N-methyl hydroxyacetylene. These are reactions concerned with the secondary aliphatic amide. And then reaction with hydrogen chloride. It forms the 3-chloropropylamine hydrochloride. Salt when treated with hydrogen chloride. And under synthesis, we have different methods. So the important ones is this. So reaction of epichlorohydrin with primary amide to form 3-hydroxyacetylene. So this is where oxime is converted into acetine N oxide. This is a reaction where ketoxime is converted into acetine N oxide. This is where lactone is converted into acetylene. Conversion of lactone to acetylene. And this is conversion of aziridine to acetylene by treatment with sulfurane. And the conversion of gamma haloamines to acetylines. So the remaining two methods are for the synthesis of azetine. This is an important method. So cyclization method, intramolecular cyclization. So where the gamma halo amines are converted into azetidines on treatment with hydroxide ion. Similarly, we can learn the chlorohydrin method, where chlorohydrin is treated with primary amine to form azetidines. This is a method for the synthesis of azetine. It is not azetidine. It is partially unsaturated azetidine, which is called azetine. It is a cycloaddition reaction. This is pyrolysis of cyclopropyl azides, which is also a method for the synthesis of one azetine. It is one azetine. It is not azetidine. Here mainly we can learn any 2 or 3 methods of synthesis of azetidines or substrate. These are the various methods of synthesis of azetidine and reactions of azetidine. Pharmacologically, it is not showing much activity, and it is also rarely occur in nature.